To problem 2, it reads, in an experiment, a seabird was taken from its nest, flown 5,150 kilometers away and released. The bird found its way back to its nest 13 and a half days after release. If we place the bird at the origin, if we place the origin at the nest and extend the positive x-axis to the release point, what was the bird's average velocity in meters per second for the return flight, and B, for the whole episode from leaving the nest to returning? So up here drew diagram. So the nest is at the origin, 0, 0. It's 5,150 kilometers to the release point in the positive direction, and it took 13 and a half days for the bird to travel back to the nest. So average velocity is displacement over time. So we have negative 5,150 kilometers because that's the distance, negative because we're heading from the release point, which is positive, to the origin, which gives us a negative displacement. Over a course of 13 and a half days, do the math in a calculator, you get negative 24.36 kilometers per day. Now we need to convert that to meters per second, so you multiply that by 1,000 to turn the kilometers into meters, then divide it by 24, then again by 3,600 to turn your days into seconds, and you get 44.6 meters per second. Actually, it's negative 44.6 meters per second. So that is the average velocity for the return trip. Part B is the average velocity over the whole trip. Again, average velocity is displacement over time. So you get the displacement, which is 0 because you start at the origin, go to the release point, back to the origin, 0 displacement, divided by 13 and a half days plus however long it took them to travel from the nest to the release point. But that doesn't matter because you have 0 displacement over any amount of time, your average velocity will be 0.